Yeah, welcome you all for another beautiful presentation on communications. Communication is the one of the core important subject for electronics graduates. In communication, normally we will cover two types of communications basically. One is analog communication, right? One is analog communication and analog communication, and the second one is digital communication, and the second one is digital communication, right? Digital communication, what is what do you mean by a communication in general? Communication is nothing but it is a process of transmission of information or transmission of message from one place to another place. Normally, it is from transmitter, normally denoted by capital T suffix X, and receiver, capital R suffix X. So, from transmitter to receiver, we will send the information in the form of signal, actually in the form of signal or in the form of wave, you can say. So that is what a communication normally, right? So normally you all aware of the wireless communication, satellite communication, right? These are the different varieties of communications normally. That is okay. So as far as our communication subject is concerned, normally this particular communication will be covered under two categories. One is analog communication, second one is the digital communication, right? Because the communication process will take place in basically two types of methods or in two procedures. We can send the information, right? So based on that, this communication is divided into, one is analog communication and the second one is the digital communication, right? Very nice. So in this communication, the very important element which is need to be defined is the modulation. Actually, this is the very basic important thing, right? Modulation. What is the modulation? Modulation, and afterwards we will see the demodulation also. Modulation and then demodulation, right? So modulation is the very important process is to be considered in the communication. Either it could be analog communication or otherwise in digital communication. In both of the communication, the modulation process is compulsorily required. It is compulsorily needed. Okay, what do you mean by modulation? Modulation is nothing but simply, in my own definition, I can define it as modulation is nothing but I can give my definition as modification. What is this? Modification. I can call it as modification. What modifies? Modulation is nothing but modification. What modifies? So, okay, this is what the simple meaning. Modulation is equal to modification is the simple meaning. Now we will go into the exact definition of the modulation. So, in order to define the modulation, we need two important signals actually. One is definitely the modulating signal is required, right? One is the modulating signal or the message signal. Clear? The very important. So now I am writing the definition for modulation. Modulation, right? Modulation. In order to define the modulation, we need two types of signals. One is the message signal. One is the message signal. Normally, this is denoted by m of t. Normally, this is denoted by m of t. Means it depends on time t, as it is message. That is why it is called m. or sometimes also called as baseband signal. This is also called as baseband signal. Okay, message signal, or sometimes also called as modulating signal. This is also called as modulating, also called as modulating signal. These are the different names for this, right? This is what the one signal which we need, and the other is definitely that is the carrier signal. One second is the carrier signal. What is the carrier signal? Carrier signal is denoted by C of t. Basically, it is denoted by C of t because the first letter is C. That is why C of t means again it is the function of time, right? This is the carrier signal. What is the difference between these two? Difference between message signal and then carrier signal? Message signal is nothing but it contains the main information which we want to send from transmitter to receiver, right? So the message signal contains the actual information which we need to transmit from transmitter to receiver, right? That is what the message signal. Whereas what is a carrier signal? Carrier means the name itself suggests that it carries certain information. What it carries, the carrier signal carries the high frequency components. It carries high frequency components actually. That is why the name carrier signal, right? So carrier signal is very very important. So in order to transmit the information over a wide range of or over a longer distance, definitely the carrier signal should be required. Without carrier signal, the message signal cannot be transmitted. The carrier signal is compulsorily, it is mandatorily required, right? The carrier signal should be, it is compulsorily required. So that is the difference between message signal is nothing but it contains the actual information which is to be transmitted from transmitter to receiver, whereas the carrier signal is contains the high frequency signal, right? That is what the basic difference actually. And how these message signal and then carrier signals looks like actually, how these signals looks like. So I will show you how the message signal is nothing but sometimes it is like in the form of our sinusoidal signal only, right? If you message signal, so if you plot or if you can, message signal is nothing but your m of t is something like this. Actually it is like your sinusoidal signal only. It is like this. It will go on. So x-axis is time definitely, and your y-axis is nothing but your m of t because it is amplitude. This is amplitude, right? So this is what your message signal basically. This is the peak to peak amplitude, you can say. This is already, you know that this is called peak to peak amplitude. So some amplitude will be there, and similarly we know that the time period, it is nothing but it is the time required to complete one full cycle, because one positive half cycle, this is one positive half cycle and this is one negative half cycle. So this is positive half, negative half, and the time required to complete one full cycle is called the time period, and this time period will repeats okay for every complete full cycle. That is why a sinusoidal signal is definitely a periodic signal. It is a periodic signal, right? No problem. This is what in general the message signal normally in general. Sometimes it could be in any other form actually, sometimes maybe triangular shape or whatever it is, but in general we will consider the sinusoidal wave, right? This is what the basic representation of a message signal. Now let us see the carrier signal, how the carrier signal look like. So the carrier signal looks like as this, like this. So if you see the carrier signal, right, carrier, so your carrier signal is denoted by C of t normally, as the C is the first letter in carrier signal. Because C is the first letter, that is why it is denoted by C of t, and your carrier signal looks like something like this. It is something like this. Something like this. It will be like this. This is what your carrier signal. This is what your C of t. This is C of t. Again, it is t only. This is what your carrier signal in general. Right? Now, so we know the message signal and we know the carrier signal. Now, I can define the modulation now. What is the modulation? Modulation, as I already told you, that modulation is nothing but modification. Modulation is nothing but modification. What do you mean by this modification? What modifies here? You know, let us see this carrier signal carefully. This is a, it is a one type of waveform actually. It is not. It is one type of waveform. So normally there are certain parameters of this carrier signal, certain parameters, namely amplitude. Remember that, namely certain parameters are nothing but one is the amplitude and the second one is the frequency, right? The second one is the frequency and the third one is the phase. The third one is the phase. These are the very important parameters need to be considered actually. So one amplitude is one parameter, frequency is another parameter, phase is another parameter, right? Now the either the amplitude or frequency or phase of the carrier signal will be varied in accordance to the instantaneous amplitude of the message signal. That message signal, that is called the modulation. Modulation is nothing but it is the process of modification of either amplitude. If you consider the amplitude, if the amplitude of the carrier signal, otherwise I can tell you like this, I can define like this. If the amplitude of the carrier signal will be varied in accordance with the instantaneous amplitude of the message signal, then it is called amplitude modulation. Depending on this modulation, we can have three types basically. So one is amplitude modulation, and second is the frequency modulation, and the third one is the phase modulation, right? Okay, it is the variation, or it is the changing of this parameter of the carrier with respect to the instantaneous amplitude of the message signal is called the modulation or modification. Therefore, if the amplitude of the carrier varies, if the amplitude of the carrier will varies in accordance with the instantaneous amplitude of the message signal is called amplitude modulation. Now coming to the frequency modulation. In frequency modulation, what happens? You know, the frequency of the carrier signal will be varied in accordance with the instantaneous modulation, with the instantaneous amplitude of the message signal is called the frequency modulation. And similarly the phase also, if the phase of the carrier will varies in accordance with the instantaneous value of the message signal is called the phase modulation. Therefore, depending on this modulation, we will have three types of amplitude modulation, frequency modulation, and phase modulation. This is what the modulation actually, right? And coming to again back to our communication, basically just I explained you what is the message signal, what is a carrier signal, and with these two signals how the modulation process can be defined, that I have explained now already. Right now coming to this communication, as we have two types of varieties of communication, that is one is I already told you that one is the analog communication, and second one is the digital communication. Now as far as your academic is concerned, or otherwise even with respect to your GATE or UPSC's IES examination, the very important topics need to be covered under these two types is, under this analog communication, you must start from amplitude modulation, right? So in analog communication, you will have your amplitude modulation. Just now we have seen the definition of amplitude modulation, and the second is the frequency modulation, right? Frequency modulation, and the third one is the phase modulation and phase modulation, right? Phase modulation. These three basically comes under your, these three modulation will be covered under your analog communication or analog modulation. These three are called as analog modulation. Analog communication are called analog modulation. And again here frequency and phase, these two are collectively called as, okay, further your frequency and then phase, frequency and phase collectively called as angle modulation. What is angle modulation? Angle modulation, okay. Collectively your frequency and phase, these two are collectively called as angle modulation. Therefore one is the amplitude modulation, second is the angle modulation. Angle modulation is nothing but it is the combination of frequency modulation and then your phase modulation. So because frequency and phase will have little bit, I mean, interrelation to each other, that's why these two are called angle modulation, right? This is what. And there are further extension also there. I mean, single sideband suppressed carrier, these are there actually. Single sideband SSB, single sideband suppressed carrier, and similarly double sideband DSB SC modulation. These we can see afterwards. These we can see what is single sideband, what is double sideband suppressed carrier signal, that we will see afterwards, because these are the very important basic building blocks of your analog communication, right? These are the three important modulations, and after knowing this, okay, then we can go little bit further extension of these modulations, right? These are what the very important under analog communication. And similarly, what are the topics, what are the important modulations need to be covered under digital communications? So under digital communication, we will start, the first is pulse code modulation. What is pulse code modulation? One is pulse code modulation. In brief, this is called your PCM, pulse code modulation. And the second one is very important, is differential. The second one is differential, okay, differential pulse code modulation, differential pulse code modulation, that is what DPCM. This is the differential pulse code modulation. And the third one is the delta modulation. The third one is delta modulation, DM. The third one is delta modulation. These are comes under digital communication or digital modulations. So pulse code modulation, differential pulse code modulation. Differential pulse code modulation is simply the extension to the pulse code modulation, and the second one is the delta modulation. These two are collectively called as digital modulation, whereas these are called analog modulation, right? I hope that you understood this basic concept actually in this first video regarding this particular communication. Just I wanted to give the brief information about this types of communication, types of modulation, and what is the modulation actually. And in afterwards, in the subsequent presentation, we will see in detail about all these categories. What is amplitude modulation, how the amplitude modulation will takes place, okay, and what is the modulation index, okay. And again in that we will see what is the power content in the side bands actually, because in amplitude modulation it has one carrier and then two side bands are there. One is called upper side band, second is called lower side band. In each side band, how much power will be there, the power content in the side bands as well as the power content in the carrier. Then what is the total power, what is the total power, okay, total transmitted power, what is the power in the carrier, all these things we will see in the next subsequent presentation, because those are the very important as far as your gate examination is concerned, even as far as your IAS is also concerned, right? All these we will cover very in detail in the subsequent presentation. I hope you understood well, and with this I just want to finish here, right? So do not forget to give your valuable observations and comments, and don't forget to even to share to your friends, okay? So because most of the students should be benefited from these presentations, and right. So with this, I want to finish off here, and we'll meet in the next subsequent presentation. Have a good day.